for such a warm introduction. Hello, everyone. It is so great to be here. It's just amazing to see you all, and I hope everyone is having a good time, and everyone online are having a good time too. Today, along with my amazing colleague, Dr. Humera, we will be talking about ML-powered anti-tracking and machine learning in the privacy space. Even before I start talking anything about this, let me quickly play a video for all of us, and let's check this video. I'm sure if not all of us here, some of us might have felt this way. Imagine having cameras all over you, tracking your movements, tracking your gestures, trying to understand where you're heading next, and tracking your whereabouts. That sounds scary, right? So this is what is happening in the web world today, kind of. And these cameras that we are talking about are the trackers. We will talk about trackers in a bit, but these trackers are the ones that are recording all of your movements, your preferences, some of the information about you, and things like that. So the intention of having something like this in the web world was to understand your preferences and to serve you right with a streamlined user experience. But it's gotten into a whole different level today. We cannot help but see some of the downsides that it's causing for all of us today. So much information about us being gathered that it's making bad people out there so easy to mishandle this data. It's helping with snooping, spying, location tracking, you name it. So that's not good. If you take a look at it, there's a lot of information that is being collected about us, and most of us don't even know if this is happening. Like, half of us are not even aware that all of this information is being collected about us. And the kind of data that is being collected varies on a spectrum of PII data all the way to pseudo data such as clickstream data. They're collecting your name, IP addresses, email addresses, your anonymous data such as ad views, your Google search history, clickstream data, etc. And that's a lot of high data, and that's a next level data. And all of this data, even before you do something on the web browser, even before you click something, all of this data sometimes even without your consent is sent to different other entities, like ad servers, advertising servers, or market retargeters, etc. And this is something that needs to be addressed. And how is all this happening? It is via web trackers. What are web trackers? So web trackers are basically a piece of code in the form of scripts, snippets. So basically a piece of code which are there on the browser and are served by a particular service. And the main intention of these trackers is to understand your behavior, understand your preferences, and to sort of create user profiling. There's different kind of trackers. The most common ones that we mostly talk about are the cookies. Like, first one we can talk about is session cookies. And these are associated with a given session. The moment you're logged into a website, you're browsing and having some experience, then you're logging out. The data that is being collected by these cookies are pretty much deleted. But next ones are the persistent cookies. These cookies are also cookies which track data, but they might be there on your browser for an indefinite amount of time, just collecting all kinds of data. And there's also different other advanced level trackers like browser fingerprinting, et cetera, et cetera. But just for the sake of this presentation, let's focus on cookies. If you see, these are some of the most common and high sources of trackers, sources of most common trackers found in the top 50K websites on the Alexa list. And some of the main players are Google, Facebook, Amazon, Rubicon Project, etc. So when you start visualizing this, this is how the image looks. For a given web page, you have like thousands and thousands of trackers associated. Now here, one very important thing is we need to understand not all trackers are bad. Like I mentioned, the whole origin of having trackers was to streamline user experience and to understand and serve the users right. And those are what we mostly call the first-party trackers. First-party trackers are the ones that are served by the website that you're browsing. For example, Amazon. I can consider that as a standard example. Let's say you're logging in and trying to browse something on Amazon, and you've been greeted with your name, and you're recommended with products that you have preferences for, et cetera. And that's basically you having a good, streamlined experience, which is needed. But the real troublemakers here are these ones, the third-party trackers. And these trackers, they are placed on your websites, and they're not even associated with the website that you're browsing. They are placed by a whole different entities that you're not even aware of. And these trackers might or might not be collecting data that you haven't even consented for. And these also pretty much make experiences a little bit annoying, no offense. Like for example, let's say you're at random point of time, you're just Googling for a product, and then you go to a whole different website, this happens, and then you're kind of tired, you want to go to some other source, just find something else, and then this happens, and then you're tired, you just shut down everything, and then sort of this happens. Yeah, third-party cookies like sort of follow you everywhere, causing that feeling of annoyance. But what eyeo is doing in this space is, we have a product called Crumbs, and Ratham, yeah, our point of contact person, so we have a product called Crumbs, and this is a privacy product. When installed in your browsers, it identifies the trackers from the URL and basically blocks them. So the way it works right now is it uses EasyList and Easy Privacy List to identify the trackers from a coming URL, and it blocks the trackers. So along the similar lines, we wanted to do something with machine learning, and that's where we brought in machine learning. We wanted to also use machine learning in identifying trackers, but another additional thing is we want to ensure that there's a good balance in the internet between user experience and privacy without costing compromise on any other side. So we wanted to use machine learning to not just identify trackers, but to differentiate between first-party trackers and the third-party trackers. And so we started experimenting a few things. And this is basically how our approach looked like. We started with data collection, trying to understand what kind of data can be used, like identifying the right data sources, and then identifying the right features by data processing, and then identifying the right kind of models. We tried NLP models, we tried graph-based, and or some of the out-of-the-shelf models, and then finally benchmark them. So I will now call Humera to take us through some of the details, technical details of these processes, and explain some of the challenges that we came across. And yeah, then I'll see you all in another few minutes. Over to you, Humera. The video.
Thank you very much, buddy. Maybe we can go back a slide and play a video. And we don't see the video?
You don't see
Peter,
it.
Yeah.
come take a look at this. this?
What's this? The numbers, they keep getting bigger and bigger.
The clicks are off the charts.
Yeah.
Yoshi, it's Walter. We're back.
Yes, sir!
More shifting, more shifting.
I need more trees. More trees? I'll get you more trees.
Hey, take a look at wood pulp.
Everything you got on wood pulp right now.
He really loves that thing.
Hello, everyone. This is exactly what we mean when we say data is your foundation for decision making. I'm Humera, Dr. Humera, and I'll be taking you through our machine learning solution that we built for anti-tracking. And we'll start with data collection. And when we start with data collection, we'll ask a few questions, very deep questions. Questions like, what data to collect? Because it's important to know what data we want to collect, because if we don't know that, we might be collecting redundant data at best, or even useless data in the worst case. The second thing that we need to know is how are we going to collect that data? Where are we going to find that data? Just like we saw in this video, we don't want our source of data to be the wrong one. And once we have that data, we also need to provide information on how we generate the ground truth. Ground truth is important because if we don't have the right labels, we won't be able to train our machine learning models. So now let's have a look at these three questions in more detail. Starting with the first question, what data should we collect? It's basically about scoping the problem. You need to define the scope. What are we going to focus on in this exact problem? Because there are trackers, yeah. There are first-party trackers, there are third-party trackers. We need to identify both of them, but we do not want to block each one of them. So that's our scope. We are talking about third-party trackers. Now, how do we actually represent those trackers? Cookies is one way of representing those trackers. But then there are other ways. We have HTTP requests. We have pixels out there. So that's our scope. OK, we want to identify these trackers. But then there are advanced tracking mechanisms as well, like CNAME cloaking or fingerprinting. We decided we are not going to talk about them at this point in time. So that was our scope that we started with. And then we moved on to answering the second question, that what are the data points that we are going to talk about? We have been talking about cookies. And what comes to your mind when you hear the word cookie? For me, it's this. But for a developer who is about to train a machine learning model, it's something else. So it's an alphanumeric combination of elements. It's a string of characters. What else do we need? We need domain information. We need URL request. We need request information. It's a post request. It's an image. It's a script. What kind of information is there? What are the query parameters that are coming up? What's the domain that we are talking about? What's the URL that we are talking about that's creating the request? So we need to know all that. So now that's our scope. This is the data that we are going to talk about. Now that we have this data, which is, as a summary, the request URL and some query parameters, we can move on to answer the second question. How do we get all this data? Which means, how do we generate the ground truth? I think I missed something. No, I didn't. So now that we have the data, we need to generate our ground truth as well. So how do we generate our ground truth? We spoke about easy list and easy privacy. I indeed missed one slide. I'll go back, because the second question was, where do we get this data from? And I still don't see it. I'll skip the slide. I'll talk about how did we get the data. So there are a number of sources which are out there. You know, there are Alexa lists, which you can use to crawl the web. because they give us the popular in domain information. Then there is the Tranco list, which is a research-based list, and we decided to go for that research-based list from Tranco so that we can crawl the web and get all these data points that I just showed you. So that was the question number 2, which I just missed in the slides, but it's OK. And the third question was, how do we generate this ground truth? And for that, we used EasyList and Easy Privacy. Now, all of you most probably know what EasyList and Easy Privacy is, and how does that play a very important role in ad detection and tracker detection. And it looks like this. We have EasyList, which have a lot of filters, and these filters are used to identify and block ads. Then we have another list, which is Easy Privacy. And it has also a lot of filters, which are there for identifying trackers. But what about this overlapping section between EasyList and Easy Privacy? What do we do with them? And what do we do with everything which is outside of both of these lists? So we thought about this, and we said, OK, we will consider everything which is coming from Easy Privacy as positive examples of trackers. And everything which is only in EasyList, we ignore them for the time being. We are not going to use them. And everything outside of these two lists will be our negative examples. And those of you who are a little bit involved in machine learning, you know that we need positive examples and negative examples whenever we are training a model. So this is how we get our positive and negative examples. Now we have our data ready. Now we took a step back and think about what kind of modeling do we use? What kind of models can we use? What kind of approach can we take? So when we took a step back and think about trackers, we realized that trackers are nothing but alphanumeric values. They are words. For example, adfilteringdevsummit.com. It's a URL which is composed of several words. And so are our domains, so are our URLs, so are our tracker names. And these words, they actually indicate that this is actually a natural language processing problem that we are solving. It's an NLP problem that we are solving, which means that in order to detect trackers, we can dive deeper into the NLP solutions that are available out there. Now, these trackers are alphanumeric elements and natural language stuff. But the machine learning model, they need numbers. They are maths majors. So we need to convert the natural language stuff into numbers. And how do we do that? Let's do a quick 101 class on machine learning, and especially natural language processing. One of the terminologies, or one of the concepts that we need here is bag of words. What happens in bag of words is that there is a sentence. You do some normalization, like lowercasing everything, removing all the special characters. You take care of any plurals that are out there, past tense out there, and then you take all the normalized sentence, put them in a bag, remove all the relationship between the words, and take them out. And when you count them, it gives you one kind of indication. That's bag of words. We can take this approach to a little further step. This is, for example, in addition to counting just the occurrences, we can compare them with the total number of words in the document. That's TF-IDF approach. That's a step better. And then we can take it to the next level, and then we have continuous bag of words. Here, instead of taking the full sentence all at once, what we can do is divide them into chunks, which are n-grams, and based on if we are talking about 2 words, that is bigrams, or 3 words, as you see here, which is trigrams or 3 grams, we can actually create something which is called as word embeddings. The cool thing about this is when we use this approach, then if we mask any word, let's say I remove the word jumps from here, then using the context of the sentence, that word can be predicted. So if I give as input a quick brown fox dash over the lazy dog, then the model can actually predict that we are talking about the missing word jumps. And then we need a total opposite of this approach. We sometimes need that jumps is the only word which is there, and we try to predict the whole sentence. So if I give jumps, the model should be able to predict that the rest of the word or the sentence was a quick brown fox over the lazy dog. And this approach is called as skipgram. Now that we have these word embeddings, and now that you have a 101 course on machine learning based on NLP, let's move towards the approach that we used and the model that we used for training. The first one that we used was fast text. Fast text uses exactly this technology that we just studied, just saw, and use them to make models. It's an approach given by Facebook research group, and instead of n-grams, which are based on words, they actually use characters. Now, what you can do is you can take this built-in model and put your data on top of it. So let's say your data has different words and it has different clusters. You put these categories. In our case, that would be positive and negative examples of trackers. You put them on top of your fast text model, and then when you give them some unknown data, some unknown new trackers, it can look at these two pieces of information and predict which category it belongs to, tracker or no tracker. Fast text is very cool because it's fast, and it's based on 290 plus languages, so it's very versatile. We got pretty promising results when we used this. But we wanted to take it to the next level, and then we moved to another modeling technique, which was BERT from Google. BERT is bidirectional encoder representations from transformations. No, we are not going to have a 101 on this topic. We can take it up offline. But the good thing about BERT is that it's based on a much more amount of data than fast text. Here, the model that's pre-trained, that's actually based on 2.5 billion words coming from Wikipedia, and 800 million plus words coming from the Google Books corpus. So since the amount of data on which this model is based, that is huge. So the data and the model is then much more robust. It's much more generalizable, but it also takes a lot of time for training. We tried this approach, and we got some nice results. So to evaluate them, what we did was we went, just recall, we just saw this slide a few slides ago, that we had some positive examples and negative examples coming from Easy Privacy and Easy List. And, Easy Privacy and nothing from Easy List. We then used this Easy List information for testing. What we did here is we took all the filters that were there in Easy List and actually shoot them on our model, and it gave us the prediction whether this is a tracker or not. We were able to get quite good results. So fast text, for example, was able to give us 80% plus score, and BERT was able to give us even 98% plus performance score. So the initial results, the preliminary results that we have are pretty cool, and we are very happy that we were able to get some good performance. What comes next? For that, I'll hand over to Pari.
Yeah. We did definitely try all of these experiments, and we did have promising results. But that doesn't stop us from doing anything more. We have our immediate next steps defined. We definitely want to diversify our data sets. We want to collect more and more examples and train our models with more and more such data so that there's more and more accuracy with the models. Definitely do performance evaluation, and ideally also want to generate that filter list, which possibly just identifies and blocks the third-party trackers as opposed to first one. So, oops, I need to take this call. Sorry. Hello? Oh. OK. You know what? I just heard from a few people that some of them here are actually tracked based on their online activities. Really? Yeah. Do you know who they are?
Actually, I also got some cues here. I need your help because we need to uncover who is being tracked here. I request all of you to please stand up so that once we are here, we can then isolate the person who's being tracked. This is really serious, guys. So I also got some cue, and what I'll do now is I'll present these cues one at a time, and if that relates to you, please keep standing, and if you think it's not relating to you, then you can sit down. And for our online audience as well, if you feel it relates to you, then you just mention that it's, you are at risk. Otherwise, when you find out that you are not at risk, you can just say, I'm safe, and take a sigh of relief. So what do we have here? So that person is on site, so at least our online audience is protected. That's a male. OK, so females, you are protected, so you can sit down. And what's next? It's not working for IO, so our unions can sit down. Maybe we were using crumbs, so we are protected. It's a PhD scholar, so at least the colleagues from industry can sit down. Flew for the summit. So I see I can shortlist it to one of the two of you. And it's you. And you can sit down at least, thankfully. And you just, OK, it's OK. I got you covered. You're protected. Ladies and gentlemen, did you notice that it took us only 5 data points to track a person, not only online, but in real physical world? That's what privacy violence looks like. That's scary. What do you think, Pari?
Definitely. And I think that's why our ML-powered anti-tracking solution could just be the one out there that can solve these kinds of problems. With that, we are now open for any questions from you.
Thank you very much.
Thank you very much.
Yeah, we're going to do the usual. And there are already hands going out there.
Great presentation. Thank you so much.
Thank you very much.
Great performance as well. So,
Thanks.
You were talking about 80% performance of the model. Could you please elaborate what does it mean? So what does the testing, how does it look like to test it?
So we were able to use almost 6,000 data points, which were coming from our easy list. Because if you recall, we were using easy privacy data for training, but not the easy list data. And we took that and we shoot them on the model, and the performance that I'm talking about, for the sake of simplicity, I just said performance score, but we mean F1 scores. So we calculated the accuracy and the precisions, and the weighted sum of them was coming out to be 80%. So in 80% of the cases, we were able to correctly identify a tracker as a tracker, an unknown, unseen tracker as a tracker, and an unknown, unseen non-tracker as a non-tracker.
Am I right that you say that EasyList is also trackers, and the target is the goal is to identify the whole EasyList as trackers, right, using the model?
You are right in the first part that there are many trackers available in EasyList as well, which inadvertently got in.
Got it. Thank you.
Thank you.
Just to elaborate, with EasyList, ad companies also track, so you have to make a decision whether you put it as a tracker or as an ad company, and normally an ad company comes first because they're an ad company. That's why even if they do track, it will go into EasyList because they're technically an ad company and have tracking things. How does it compare with easy privacy overall? Like when you find these, how effective is this? Say if you just ran easy privacy by itself versus the email version of this, is it more effective, or is it? just as effective as easy privacy is.
So you mean easy privacy versus easy list?
Easy privacy versus the email generated list, I guess.
The one that machine learning model
Yeah.
potentially would generate the third-party.
Okay, that list. This is something which we still need to evaluate. The initial results are very good. But if I understand the question correctly, you mean to ask that if we use our machine learning model to generate a similar list, how would these two lists compare?
Yeah.
This is something that we still need to evaluate. Right now, a very big problem is for us to generate the ground truth data, which is unknown, unseen, and manually label them. Because our initial results with easy list, they are pretty good. But to do this evaluation at a large scale, we need to generate more ground truth data so that we can use it for testing. So it's too soon to say how would these two lists compare.
Yeah, it'd be good to see if we missed anything in easy privacy, that something that was picked up by this email generated thing that we could actually implement ourselves automatically. Like, okay, we found a tracker that we didn't pick up ourselves, but it's being picked up by the script, and we can just roll out a patch, for example. That would be really helpful.
That's totally true.
Yeah.
Because you want to take this up further?
No, go for it, but I can add on the comment later.
Okay. You are totally right, because easy privacy has a number of problems in its current form. It's manual generated. It's not professionally handled. It's not under control of a central authority, which might be a good thing, but when it comes to maintenance and somebody taking ownership and responsibility, then this becomes a bit challenging. And having an automated solution to create filters, even remove filters, that would really help and save the day and be fast.
Well, good, thank you.
One small thing I just wanted to add is, right now, if you really want to compare the easy privacy with the potential list that we are planning or aiming to generate, then the one that we are really aiming to generate is really the third-party trackers, which has like clear differentiation between the first-party versus the ones that are third-party trackers. So hoping that we are able to identify just the third-party trackers and not necessarily completely block the first ones.
So you mentioned that you're using an NLP model, and you're using the URLs, I presume, as the data. So I'm curious how you tokenized the URLs, if you could say more about that.
So we take the URL, take each and every character as a separate token, and we assign them a numeric value. There are a number of ways how we can proceed further. One of them is that we create then metrics out of it. The rows of the metrics are the domain names. The rows are then representing the filter hits, and then using that combination, we proceed further. And then this is only one of the different parameters that we were talking about. There was the request URL and the request parameters as well. There we actually use one-hot encoding. So there were 12 different types of request parameters that were there, image, script, post, etc. So we took a 12-element vector and used one-hot encoding for representing them.
Got it, thank you.
Mm-hmm. Awesome.
Excellent.
Good throw.
Good catch.
I got a couple of questions. So the first thing is, have you made the data public from your research?
We are in a very preliminary stage to make the data public, and it's actually easy list and easy privacy, and the Tranco list, which is all public information.
Right. I meant the ML generated list. I was curious to have a look through it.
Not yet.
No? Okay.
We are not yet
very
there.
preliminary stage.
Fair enough.
Yeah.
We are not yet.
The other question was, I don't know if this is really for you, but is this with an idea to having some kind of acceptable tracking program, like the acceptable ads thing?
That's a very good question.
Yeah.
But this is definitely not for us.
Okay.
That would be a good add-on feature, maybe later part in the roadmap, but right now we don't have that in our radar at least.
All right,
Add it to the backlog.
Yeah, thanks for the idea.
I'm sure I'm not the first person to think of that.
Anyone else? Okay, I think I might. There you go.
That was dangerous. Hello. What data points do you use to identify whether it is tracker or not? I understood that you use the URL, but do you use the cookies that are transmitted with the request? Because it might be like really important.
No.
Might be a good idea to do.
That's a good idea.
Yes.
Yeah. Right now, we are just looking at the URLs and
The request?
The
and
request
the
URLs.
domain names,
Yeah.
the query parameters.
Pretty common. The cookie names are pretty common for trackers, for different tracking systems, because there's always will be some kind of a UID, session ID, and this kind of stuff.
Exactly.
Awesome.
Sorry. So it picks up trackers, say, if we look at Google Analytics or Google Tag Manager, you could mark that as, obviously a tracker. But with easy privacy, obviously there's a lot of sites that will break if you decide to block said trackers, because like the checkout button, for example, is bound to a script that checks that if it's has an assigner value for Google Analytics or Google Tag Manager or whatever, it will break. So this wouldn't pick up false positives where, while it's a tracker, it could potentially break a site, You understand what I'm saying? It's like sort of, it can't distinguish whether that tracker is going to break the site or not, will it?
That's a very good point. In fact, this is part of the future plan as well, that we do not block everything as, because there are essential trackers as well. In addition to first party, there are these essential trackers as well, which break the site utility, and we need to work on making sure that we are not breaking the site utility as well. We need to think about how we can actually protect user privacy by maybe reducing or filtering out the private information that is being transmitted to the from outside of the user's machine by blocking something like that and not blocking the whole tracker as it is. But this is also part of our future future work, as the next steps. Detecting the trackers was the first one.
Behind you.
So are you saying that the main differentiator between the first-party tracker and the third-party tracker right now in this approach is the domain name?
Domain name combined with the URL request,
Okay, so if there is a common sort of group of interest, let's say Amazon and Twitch, if the actual tracker is by Amazon on the Twitch entity, which still is a sort of first party, that will be tracked as or treated as a third party, right?
Pari, you want to take this?
Well, yeah, that's one of those exceptions where I think
we spoke about it a lot.
Yeah. Yeah, those are some of the exceptions that we also want to consider in the future. Like the Twitch would be considered a third party, but not necessarily a third party. So I don't know. I think we do definitely have some of the open questions, and we are at a preliminary stage. So I mean, great that such good questions and ideas are coming from this crowd. So this will definitely help us with taking things on those lines. Definitely, that's something I would like to say at this point.
And we have been discussing whether we want to use this first-party versus third-party differentiation as an input to the machine learning model, or we want to use the machine learning model to train on distinguishing between the first-party, third-party, and non-trackers. So far, it was like just tracker, non-tracker data, but the future plan is also to have first-party, third-party, non-tracker information detected by the model. We have a question here. Yep. Oh.
Yes, a couple of months ago, I was on an online marketing event, and they were worried about 80% of their jobs because of the new cookie law. What is your view on this?
80% of their jobs can be lost because of the cookie blocked or cookies not blocked.
Yeah, they were not allowed to use cookies anymore for their marketing tracking events. And it's their job. I was surprised. 80% is a lot.
80% is a lot. And I think this is where it comes back to having a fair internet. We really don't want people to lose their jobs just because they cannot reach their customers. And therefore, we really need solutions like privacy protecting ad solutions, like crumbs, which can actually, this was not a big question, but yes, definitely. But definitely. And that's why at eyeo, we are actually focusing on bringing a fair internet to the user so that the publishers, the advertisers, the users, they all have a win-win-win situation. Nobody has to lose their job because they cannot reach the users. And that's why also when we block ads, we don't block everything. This is not ad blocking Dev Summit. This is ad filtering Dev Summit because we totally understand the concept that we need to make sure that some ads need to reach the users. They have to be filtered, not just blocked. Thank you. That was a very good question. I think we are over time.
Yeah, I think we're closing the questions here, but people can still reach out to you afterwards, during networking later on, or also the breaks. Thank you, ladies.
Thank you very much.
Big round of applause.